980 kg sports car collides into the rear end of 2300 kg SUV stopped at the red light. The bumpers lock, the brakes are locked, and the two cars skid forward 2.6 meters before stopping. The police officer, estimating the coefficient of kinetic friction between tires and road to be 0.8, calculate the speed of the sports car at an impact. What was the speed? This is a typical combination of two conservation laws problem. First of all, you have to assume that collision happened to occur so fast that during this collision, neither one of these two cars actually moved. Of course, it's a little bit artificial suggestion, but having in mind that collision happens to occur very, very fast, it's reasonable. So first we will use conservation of momentum law. We will assume that at the horizontal surface we have SUV here with a mass SUV equal 2300 kilograms and speed of SUV initial is 0 meters per second because it stopped at red. You have sport cars with a mass of cars MC 980 kilograms and initial velocity of the car V initial, which we have to find out. This is what happened before the collision. After the collision, we have both cars locked together. So they move at the whole mass, M car plus M SUV. So you have to add 980 and 2300s, and you will have 3180 kilograms, and you will have final velocity of this combination VF. If you will take x-axis in both cases to the right and calculate initial momentum, which is entirely to the motion of the car, mass of the car times initial velocity of the car, and final momentum, you will have mass of the car plus mass of SUV times V final. You can claim that P initial equal P final, which gives you connectionship between V final and V initial. We have mass of the car times V initial equal mass of the car plus mass of the SUV times V final. Now we need to connect V final, final speed of the combination of car and SUV, with the skid path 2.6 meters. So we can use here work-kinetic energy theorem. We can claim that final kinetic energy of the combination car and SUV minus initial kinetic energy would be equal to the net work done by the friction force. And final kinetic energy is 0 because both SUV and sport cars ended up at being at rest. Initial would be 1/2 mass of the car plus mass of the SUV times V final square. As for the work done by the friction force, this would be displacement or length of the path 2.6 meters times friction force, kinetic friction force, times cosine of the angle 180 degrees, because our displacement and force opposite to each other. So you will have minus 2.6 meters times, and the kinetic friction force is kinetic coefficient times normal force, which is equal mg. So mc plus ms, total mass, times g. If you will combine everything in one equation, you will have 1/2 mc plus ms v final square equal, with sign minus of course because we have 0 minus that, equal minus 2.6 meters times mu k, coefficient of kinetic friction, times mc plus ms g. Mass will be cancelled from both sides, minus will be cancelled from both sides, and you can come up with a conclusion that V final would be equal square root of 2 times 2.6 meters times 9.8 meter per second square, this is our g, and times mu, which is 0.8. Then you will plug in everything in the equation for the conservation of momentum, and you will see that your initial speed of the sport cars will be total mass of the system, which is 3,180 kilograms, divided by mass of the car, 980 kilograms, times your V final, which you will put here. If you will do calculations completely, you will come up with about 21.37 meters per second. We did solve the problem completely.